there's also different words that mean x and y. So sometimes it's going to be really straightforward. It's going to be x is 3 minus a number, or 3 minus x even. So sometimes they might just say the letter. Other times they'll make it a little bit more coded. So the x, actually you learned this in science, and you definitely learned this last year, the x is an independent variable in a function. While the y is the dependent variable. The x can also be referred to as the input. It's the number that we're putting into the expression or equation, and we're getting an output. It's the input and the output. And the way we phrase these two things with functions, when we learned about whether it's a function or not, we talked about them as domain and the range. You can't really remember these. The easiest way to remember these is that the x always goes into the equation, and we have an output for that. And the word in is in each of the vocab words for x. All right, so we're going to write sentences for each of these examples. There's more than one correct answer, but I'm going to have you copy down these exact ones just so you can see an example of what this might look like. I'm going to write them sometimes in mathier ways, sometimes in really simple ways. I'm going to start off really simple. Y is 3 times x plus 1. There's more complicated ways that you could say that, but that is just the simplest way. Y is or equals 3 times that x plus 1. I'm going to get a little bit mathier with this one. The output, the output equals 5 less than the input. Remember, even though the 5 happens last in that equation, even though it's there really, in my sentence, when I say it as this, 5 less than something, I'm changing the order of that. I have my input first, my x comes first, and then I have the 5 less than that, which is really just subtracting from it. All right, on the next one, I'm going to say y equals twice a number subtracted from 5. And that might seem weird too, but when I have that phrase subtracted from, even though I say this twice a number first, it's actually happening second. I'm taking that away from the 5. I start out with 5, and then I subtract from that, I subtract 2x. All right, the range for the y is 1/2 of the domain minus. Again, there's a bunch of different ways that you could say these. I just want to give you certain examples. When you see that phrase 1/2 of, that's multiplication. It's 1/2 of the domain, or 1/2 times the domain. On the next one, I'm going to use input and output. The output is, and this one's a little bit tricky because we have a big fraction there, saying that's actually kind of specific. So I'm going to use a mathy word here. The sum is, sorry, the sum of, we gotta say input of the input. And 9. So all I've said so far is the sum of the input and 9. That's the addition problem on top. And I want to have all of that divided by 4. Now, if I just say divided by 4 right then, I'm only saying that the 9 gets divided by 4, but that's actually not what I want to say. I want to say the whole thing gets divided by 4, so I'm going to put a comma there. That implies that everything that came before it, all of that is divided by 4. You need that comma to show that you're actually dividing the entire expression there. The whole sum gets divided by 4, not just the 9. It's really similar on the next one. I'm multiplying the entire x minus 2. It's all getting multiplied times 3. It's not just the x. So I'm going to say y equals 3 times I'm not going to use a comma here because that wouldn't really make a whole lot of sense in that sentence, but I'm going to group them in a different way. I'm going to group them the same way I group this. When you use those mathy words, you're using a specific thing. It's either the sum or the difference, where you're using that whole thing. That entire thing needs to get multiplied by 3. I'm multiplying the entire thing times 3. It's 3 times the difference. It's 3 times the whole subtraction problem. It's not just multiplying x times 3, it's multiplying 3 times the entire subtraction problem inside. That's what I'm trying to say there. So I'm going to say 3 times the difference of x and 2. Right, I think going the other direction is a lot easier because there's basically just one right answer. You don't have to make up whatever you want for the sentence. And the way I want you to do this is actually labeling every step of the equation, every step of the sentence, every part of it, with whatever it's talking about. So you translate that directly on top of the sentence. I want to say y is equal to, I know that's going to be my equal sign, 6, so y is equal to 6 less than 1/3 of a number. When I see that phrase less than, I know it means subtraction. And then I have the phrase 1/3 of a number. That means I'm multiplying 1/3 times some number. I don't know what that number is, so I'm going to label that as x. Now I have that specific phrase in there that's telling me to flip these around. That phrase less than is saying I have to change the order of that, so y equals. That part stays the same. It's just the two things on opposite sides of that phrase. This thing, the 1/3 of a number, and the 6. Those things switch order. The 1/3 of a number and 6. It's 6 less than 1/3 of a number. Next one says the product, the multiplication problem between 2 and a number, is decreased by 3, and that is y. You can write it in that order, or I'm going to actually flip it around. I'm going to put the y in front. Generally, when we see functions, we're going to see the y up front. We're going to see this in what we're going to call slope-intercept form. So we can write it in that order, or we can flip the order around. We can write in what we're going to see as slope-intercept form, where you see the y first, the y equals, and then the expression for s. That's 2x minus. Next it says the output, the y, is equal to, the output is equal to 2 times the input, 2 times our x. That one's simple, y equals 2x. Next it says one more than. More than is telling us to add. More than the quotient of these two things. Whatever comes next, it's dividing those two things. It's the quotient between those two, which is x divided by 7, and that equals, that is 7. Sorry, that is y. Said that wrong. Now, I got a couple things going on there. Usually, when you see the quotient, we're going to see that as a fraction. So we're actually going to put the x over 7. We also have one of those switching phrases, more than, it's one more than that quotient. So I'm going to put the y first again. That's not switching the order, that's just rearranging it just because I like seeing the y first. Y equals 1 more than the quotient of x and 7. And our last translating one, the independent variable, that's our x, is subtracted from 10, and that is the dependent variable, which is y. So again, I have to change the order of that. I see that phrase subtracted from. That means it's actually going to be 10 minus x. The independent variable, the x, is subtracted from the 10. I start out with 10, and then I subtract away that x. And that is the dependent variable, or that is y. Okay, so we're also going to see these, rather than just directly translating the sentence into an equation, we're going to see them in a word problem where you actually have to break down what that word problem is saying, pick out the key words, and write that as an equation. So Valentina's total monthly cell phone bill costs 10 cents per gigabyte used, and a flat fee of $45.60. Write an equation for the monthly cost, which is y, based on per gigabytes used, which is x. Now this is helpful because it actually tells us exactly what they want us to label the variables with. The total cost, the monthly cost, is that y. And in general, all of these equations are going to have the same form, at least for now. You're going to see this form where it's y equals some expression in terms of x. And that's exactly what's happening here. It's 10 cents per gigabyte. It's times the number of gigabytes, which we don't know yet. That's the x. It's 10 cents times the number of gigabytes, which we don't know yet, plus that flat fee. A flat fee is just a one-time fee that we have to pay. We're paying a flat fee of $45.60. And that's it. All we have to do is translate that into an equation. And the next one says, Diego and his friends went to the movies. Tickets were $6 per person. They each received a $1.50 student discount. Write an equation to represent the cost of the tickets, y, based on the number of tickets, which is x. So notice I'm just highlighting the parts that have the numbers in them. Really, it's the phrase that goes around the number, $6 per person. They each received a $1.50 student discount. Those are the key phrases there that are going to generate this equation. The total cost is our y, and that equals 6 per person, $6 times the number of tickets that we need to buy. But we're also getting a discount for each person. That's important. It's each person. So that's actually also going to be multiplication. It's $1.50 for each ticket that we buy. But a discount, actually that should have been one of the mathy money words. We're actually subtracting there. If we're getting a discount, we've just learned about this, that we subtract that amount. So we're subtracting $1.50 for each ticket that we buy. Then the next one says, Shahali buys 3 pairs of pants for $18.50. Sorry, they're $18.50 each. That's really important. They're $18.50 each. Actually, I'm just going to start with that. 3 pairs of pants for $18.50 each. There is no X in that part of it. Even though it says that phrase each, that word each, we're multiplying it, but we already know the number that we're multiplying by. We're buying 3 pairs of pants. And some number of shirts for $15.50 each. We don't know the number of shirts, so that we need to actually multiply by X plus $15.50 for each shirt that we buy. The number of shirts is our X, that's what I have labeled there. The total cost is our Y, so this all equals Y. That's the pants plus the shirts together, that equals our Y. All right, the last one, there's 2 numbers. The larger of the 2 numbers is 9 more. The larger of the 2 numbers is 9 more than 1/4 of the smaller. Write an equation where X is the smaller one and Y is the larger. Okay, so I'm just going to break this down. Actually, this is more direct translating. The larger one, we're calling that Y, is, that equals, Y equals 9 more than, that's 9 that's being added to something, so I'm going to do plus 9 on the end of this, 1/4 of the smaller one, 1/4 of X.